This is part one of integrity in data security. In this part, we're going to talk about integrity in data security by using hash functions, error detection, error correction, validation. In this video, which is a short one, I'm going to cover some basic examples of handling input or how you can code to prevent integrity threats. This will, for obvious reasons, not be a complete list of all possible scenarios. I'm just going to have something to get you started. I'm just going to give you the basics, show you 3 common examples. So let's start with the first example is regarding scanning of text to find numbers, either integers or doubles. So if you just blindly grab the next int or next double, those scanners can get confused because if the number isn't properly formatted, there will be an error. There's nothing to parse. So if it tries to parse 1s as an integer, it will for obvious reasons not handle it well, and it will throw an error. So you have to check first if there is another int or if there is another double before you try grabbing something blindly. So that code example shows you how to properly handle this problem. So you check first if it's if the scanner has next int or next double, if we use double instead, and if it's true, then you ask the scanner to get the next value. Otherwise you skip or do something else. So that's called a safe scanner implementation. Because the golden rule of dealing with input is do not trust them. Check it for yourself always first. The second example is a very common error when you try to divide by 0. Obviously that's not possible. So assuming you've safely read in the next number and you want to divide by it, and it turns out it's 0, now what do you do? If you don't do anything, the program will crash and or throw an arithmetic exception. So what you do is you implement a safe division. That is, check if the number you parsed in is 0. If not, you divide by it. Otherwise, you handle that error. However you handle it depends on the context, obviously. If your program's primary purpose is calculations, then you might just allow the exception to be thrown and handled by the receiving process, the next level up. A bad implementation, and I can't stress this enough, it's a really bad implementation, but I've seen it often enough, might just return 0. I never recommend that, though. The third example can be a particularly nasty one. It's a thing called integer overflow, and what it means is that the value of your integer has surpassed what the operating system or your programming language allows. So what's particularly bad about it is that it can be an error that's really hard to notice. So if it's an error, if your programming language or operating system doesn't allow integer overflow errors and it just throws those errors back at you, that's fine. And it's handled by the operating system. However, in Java, by default, if an integer overflows, it just wraps around and starts over again. So what does that mean? If you take a look at that code snippet in the box there, we start with declaring the max int variable, which is a really high number, as you see. And then if you see in the the print line statement, we add a 1 to it. And what does it return? So what does it print out? It prints out a negative number instead of throwing an exception, which is really, really bad. And you see that there's a table there at the bottom that like there's the inclusive range of what primary type values can be in Java. Sometimes it depends on the operating system, but Java works on a virtual machine, so it is always the same in Java, whatever operating system you're working on. Other languages depend on the operating system to set these values, so it might change in those. Now, to deal with the integer overflow error, or one way of dealing with it correctly is to implement a safe addition, similar to the safe division that we saw before. The code snippet above in the red box is how you shouldn't implement it. The green box, or the code snippet in the green box, is the correct way of doing it. So what it does, it checks if you overflow, or the integer overflows by adding the two integers together. And if it does, you specifically tell the addition to throw an arithmetic exception. Otherwise, you add them together. And this is the right thing to do here. You don't want to you don't want the system to believe that everything was fine when it added two values together and had something completely different from it, which might not even be reproducible later on when you're trying to debug things. Now, the common thread in these three examples is validation of input and arguments, which we will expand on in the next video.